This question looks messy at first, but once you spot one simple factor, it becomes super easy. Let's solve this step by step. Our question is, solve the equation k square minus k raised to the power 3 equals 12, and find all values of k. The plan is, first we bring everything to one side, then we factor the expression, and finally we solve each factor to get the values of k. So in the first step, we take 12 to the left side, and the equation becomes k square minus k raised to the power 3 minus 12 equals 0. Now we rewrite 12 as 4 plus 8, because 4 is equal to 2 square, and 8 is equal to 2 raised to the power 3. So the equation becomes k square minus k raised to the power 3 minus 2 square minus 2 raised to the power 3 equals 0. Next, we group the terms with power 2 together and terms with power 3 together, giving k square minus 2 square minus k raised to the power 3 plus 2 raised to the power 3 equals 0. Now, both parts match special identities. K square minus 2. Square is a difference of squares, and ki cube plus 2 cube is a sum of cubes. Using the formulas, a square minus b square equals a plus b times a minus b, and a cube plus b cube equals a plus b times a square minus ab plus b square, we get k plus 2 times k minus 2 minus k plus 2 times k square minus 2, k plus 4 equals 0. We factor out the common term k plus 2, giving k plus 2 times k minus 2 minus k square minus 2, k plus 4 equals 0. Opening the expression, the inside simplifies to minus k square plus 3k minus 6, so we now have k plus 2 times minus k square plus 3k minus 6 equals 0. From here, we solve each factor. From k plus 2 equals 0, we get the first solution, k equals negative 2. For the quadratic minus k squared plus 3k minus 6 equals 0. We multiply by negative 1 to make it positive, giving k squared minus 3k plus 6 equals 0. Using the quadratic formula, k equals b negative plus or minus square root of b squared minus 4ac over 2a, we get k equals 3 plus or minus square root of 9 minus 24 over 2, which is k equals 3 plus or minus square root of negative 15 over 2, and square root of negative 15 is square root of 15 times I. So the two complex solutions are 3 plus square root of 15 I all over 2 and 3 minus square root of 15 I all over 2. The important idea here is that rewriting 12 as 2 square plus 2 cube allows us to form perfect square and perfect cube patterns that make factoring easy. So the final answers are k equals negative 2, k equals 3 plus square root of 15, I all over 2, and k equals 3 minus square root of 15, I all over 2.